Hey everyone, and welcome to SST 1.0 Conf. My name is Dax, and for those of you that don't know me, I'm part of the core team at SST. As you can tell from our video, we're really excited to be celebrating the launch of SST 1.0 in a big way. Before we get started, make sure to join the V1 Conf channel in our Slack so you can post any questions you have. We'll be answering those during the intermission. To kick things off, our CTO Frank has a few words to share about the journey to 1.0.
All right. Hey, everyone. My name is Frank. I'm the CTO and co-founder at SST. If you're in Slack, the chances are we already chatted a bunch, and it's finally really great to see everyone. Really excited to be here to talk a little bit about SST. Let's quickly dive into like how we got here. Like a brief history about us. When we first came across serverless, this was 2016-ish, and it just made a ton of sense. Just writing the code and everything else was taken care of. At least that was the idea back then. So we set out to describe what a serverless stack would look like. Initially we wrote a guide that took the best tools available and help you build a full stack serverless app. Then we looked at the parts of the setup that we thought what was the hardest part to deal with, and so we started with the deployment. We wanted like a really simple git push to deploy way to deploy our serverless apps. So at first we built Seed, but more and more people, as they started using Seed, we found they constantly run into the same problem. Like I would get these messages in Seed support where people messaging me are like, "Hey, I'm new to serverless. Seed is awesome, but do you have any advice on our local setup?" Everyone was struggling with the poor local development experience, and the major players in the space just didn't seem all that interested in solving it. So instead of us fixing the local development experience in the existing tool, so we decided to create our own framework. That leads to the first feature we're launching in SST v1, which is live Lambda dev. So if you remember the days prior to SST, the local environment usually looks like a collection of mocked AWS services. Essentially, you're trying to mock every single cloud service on your machine that you're using in your app. But given these mocked services, they don't necessarily behave exactly the same as the real services. You often run into weird cases that only happens in production. So to avoid this, many teams kind of adopted the approach of rebuilding and uploading the function code on every code change. The obvious downside for that is the iteration speed is really slow. The cycle of making a change, push it to the cloud, uploading it there, and that cycle usually take 2 to 5 seconds, which is a lot slower to what we are used to. So when we launched SST with live Lambda dev, that allow you to test your serverless apps without mocking or uploading. So you can test, you can set breakpoints and step through your code step by step, and the code changes get picked up in milliseconds. So that's local environments. And then we looked at what's the next problem we should solve for people, which turns out to be the creating resources. If you're new to AWS, there are 5 different ways to create an API, and for a given API, there are 4 or 5 different format you can configure the access log. It lets you. And so that's why we build out these like SST construct as like a simple way to define the infrastructure in your app. It lets you create these high-level pieces like API and messaging queues, database clusters, all without knowing all the nuts and bolts of how AWS resources work. If you look at this example, what I call like a day one usage of an API. So behind the scene, it also configures a course, sets up the access log, enables the X-ray monitoring, all the advanced stuff. They all come with sensible default. And of course, these default can be changed. You can put a custom domain at some point, or you want to restrict your course to only allow certain R regions, right? I describe this as like a day end usage. And for those of you who are the AWS champions in your team and who are super familiar with the underlying AWS resources, you could dive into the construct and turn every single knob on the underlying resources. So in essence, anything you can do in CloudFormation, you should be able to do in SST. And the next thing I want to talk about is the editor integration. This is one piece we actually put in a lot of effort to get it right. We want to make sure every single field, every single prop you're trying to access, you're trying to define, they're auto completed and type checked. If you make a mistake, we want it to be caught upfront in your editor. This is more important in when you're dealing with like deployments where when the deployment goes through CloudFormation, that's the most time-consuming part. So any bugs that you introduce in your infrastructure, they should be caught at development time instead of the deployment time. Yeah, so here's the example, right? So say some of you are super excited to try out the new Node 16 runtime, and for some reason you're so excited you misspelled Node. And given that you're not like a Python person, so you misspelled Node, so over here you don't have to wait for CloudFormation to tell you that, hey, the provided runtime does not exist, and you have to wait for CloudFormation to roll back. But this instead, the typo will get caught in the editor directly. We also found that people have a really hard time working with AWS console, right? That's why we created this SST console. It's pretty much a web-based dashboard that knows your app. Anyone who have used the AWS console knows that it's overwhelmed in the amount of features they have, and most of them we're not even familiar with what they do. So we figure out the only way to simplify the console experience is by knowing your app and only put in the things that are relevant to you. So taking out everything that's irrelevant. If you're using, like IAM permission to authorize your API, why show the option for JWT authorizer, user pool authorizer, the custom Lambda authorizer. If we know what your app is using, we should be able to cater a perfect console experience just for your app. That's SST console. So, with all the features I just mentioned, it brings us to a point where we feel SST v1 is very stable. Over the past years, tons of teams have built really amazing things in SST in production. Even for, when I was organizing, try to coordinate today's event, I had a chance to speak to all the other speakers. I was like genuinely intrigued by the things, some of the things that they built. Zach was telling me how they are using step function in SST to building out and testing out like the Comcast network infrastructure. And when Tamara told me how they are using like SST to spin up this fully fledged environment just to run integration tests, so I told myself, it's like, hey, I really need to build something too to be able to earn a spot on the conference. So the event website you guys sign up with, I actually built that using SST, and unfortunately it only took 4 lines of code. This deploys the S3 bucket, it puts a custom domain, and it found a service out behind a CloudFormation CDN. Not a lot of coding, but it got the job done. Okay, I think that wraps up the keynote, with SST v1, I really want to celebrate this like a milestone, the significant milestone of SST development. And also I want to take this chance to share, amazing stories from the broader community. Later today, Dax will talk about the next phase of development for SST. He'll be demoing the GraphQL stack we put together. And to close it out, Jay will share a message from the team. All right, thanks for joining us this morning, and we hope you find the talks friendly. And grab a coffee and let's get started. I'll hand it back to Dax.
All right, thanks, Frank. It was great to get that overview. So now we'll hear from some people from our community. So to kick things off, first up, we've got Karolina, who's a senior engineer at Endpoint. She's been a technical leader for 20 years and enjoys trying out new technologies.
Hey, everybody. Super excited to be here. Today I'm going to be sharing a few experiences that my previous team had, and how that affected our efficiency, and as part of that, how we ended up knowing about SST, using it, and being part of this community. All right. So this happened at my previous job at a company called Exos. Exos is a human performance company. They have been in the industry for over 20 years. They have like different services and solutions. Back a few years, the main target was like training for professional athletes and teams. And also like in the corporate side, they offer solutions for clients so their employees could perform better. Just a few examples, they manage facilities where they had like special devices that run Exos applications with their own technology that are allowed like for better workouts and trainings. And now I just want to talk about few of the issues that I mentioned like affected our efficiency. I would say like the top three were like the architecture and the tech stack. We had like really like old applications that became like big monoliths. Then we tried to introduce like microservices over the years, but we were still like relying on tools that were not the best. And as you know, like it's always like hard to like completely change things when you're also like in the process of delivering and all that. Also, we didn't have like a good DevOps culture. That was like a big issue. Can give like a few examples. For instance, there was kind of a disconnect between the development team and the DevOps teams. Like usually like they didn't know, like developers didn't know how things work in production. There were differences like between like local environments. Also, we had like really slow deployment process. And well, I think that gives the idea. And then another issue was local environments. We tried many things across the years. For instance, the VMware VirtualBox a long time ago. Then also Vagrant, I don't know if you remember about that. Then we replaced that with Docker, and then also local stack for a few small pieces that were using serverless. But at the end, we always run into issues. Then around year 2020, I would say before that, we were like in the technology side, we were working like in improving things. And we already had like approval for refactoring things and moving into new architectures, but also the company was already looking for a change in the product based in new, just like in new requirements by people, right? And then the pandemic arrived, and we were forced to do this like super quickly because like all the facilities had to shut down. We needed to keep like offering like services to the users, and at the same time keep coaches busy. So the team really had to put something together like real fast, and that's how we got to develop a brand new product. This is just like the final version after like many months, but at the beginning, something had to be put together like in a month, I would say, like from the idea about the product to the implementation and deployment. And the good thing is that we already knew about these issues that I mentioned, and we knew what we wanted to do. Another good thing is that the developers were empowered to do what they wanted to do as long as we delivered. So basically, like the solution was like an app where the users could have access to live workouts, also to just workouts, on-demand workouts in general, access to consultations with their coaches, and a few more things. Now I'm just going to talk about the technical details, I would say, for this. As I said, we will move to the technology that we wanted, completely using a serverless and event-driven architecture. Well, and as part of that, using like all modern things like API gateway, like SQS SNS for event-driven communication, DynamoDB using single table design, among other things. Then for the infrastructure and developer environments, I have to say, like the beginning, we didn't use SST. I'm not sure like if it was around back then. We used other tools that rely like in YAML, and I have to say that eventually that became like a bit tedious, and we still didn't have like a good solution for the local environments. So we eventually, as part of trying to solve that for like a different revision like of the product, it was nice that I found out about SST and got the support from the team to test it out and see like if it could work out for us. So which we did. At the end, the team, like everybody was super happy because it completely improved the local development experience. But not only that, the developers were like super familiar with the infrastructure, and things were like really close to what they look in production. So when they were able to participate like more in, as part of all that like deployments, debugging issues, etc. CI/CD was implemented using AWS Code Deployed. So we went from having like deployments every month or so to having like daily deployments, which was great. Then, as we thought it was going to be, for the nature of the business, by using like a serverless architecture, we were able to have like a really low cost implementation, and we tracked this through AWS Cost Explorer. And summary, complete turnaround and delivery efficiency. So just wanted to share this and to say like there's like a mix of things that apply when you want to talk about efficiency. It's not only, it's like the tools, but you also need to have this culture, right? About the DevOps culture, empowering developers, and I think that's it. Super happy about being part of this community, and just like thanks to the SST team, because they always have been like there for any questions or issues that come up.
Awesome. Thanks for that, Karolina. So next up, we've got Ross. He's been developing for the web since the late 90s, has done work for companies like Sencha, Twitch, Nike, and many more. He's been part of the community for a while. I think the ESM support that we added to SST, he was a huge help there in helping me figure out how to get that all to work. So we're happy to have him here and excited to hear his talk.
Hello. I wonder if this is delayed. Like, I wonder how long you guys just watched me sit on the screen. I'm Ross, and we're going to jump right in. We don't have a ton of time to do this. I have some slides. So today we're going to be talking about hydrating functional web apps. This is a whole bunch of words on the screen, but we're gonna bust through this really quick. If you don't know about the tech, that's what we're gonna talk about in the slides, just really quick. Then we're gonna jump into code demo. So that's not what we wanted. We gotta stay where we are here. Over here, let's do this. Okay, yeah, this is me. Dax already talked about all my stuff. The picture's like slightly outdated. So for me, we're just going to talk about what serverless is really quick. So Mark Twain says it's a shift in mentality and process with a focus on solving relevant problems instead of solving every, I don't think Mark Twain said this. I think this might have been me. Either way, the point is the shift is solving the problems that are important for your customers and whatever you're making. You're not trying to solve all the problems every time over and over and over, right? You're not trying to recreate server instances and reinstall Linux and get the right node environment and all this kind of stuff, right? We're going to skip all that. We're going to focus on just the problems we want to solve. Again, one of us said this. I don't remember who. All right. And today we're also going to talk a little about functional web apps. Real quick, do we need another buzzword? Of course we do. So the reason that functional web apps exist is to remove some of the ambiguity in the word serverless. Serverless means a ton right now. It could be containers and Heroku and Versatile, like all these different things are serverless. A functional web app is very, very simple, and it kind of goes back in time a bit to almost like the PHP days. We're going to make a request somewhere. A function is going to run, and it's going to return some HTML. Either that or it's going to be static. Usually this is backed by some kind of managed database to keep all of our state, probably Dynamo. And then we have infrastructure as code so that everything is deployed together, right? Easy, right? Been there for years. All right, so the other big piece of this is serverless stack, and Taylor Swift really said it the best. It's a JavaScript-based framework that allows developers to leverage their existing knowledge to make AWS applications at any, I don't think she said this. This might have been me too. The important thing here is that it's JavaScript, and it can you don't have to learn something new. You can use JavaScript that you already know, any complexity, any scale. All right. That's it. That's the slides. We're through it. Let's do this. We're going to jump right in, and we're going to put these things together. So that was that. All right, we're in it. Let's do it. All right. I'm going to lower my mic volume. Someone just asked me to, so I'm going to do that right now. Okay, so here we go. We're looking at the stack. Here in the stack, this is just a very basic SST app that we got running. We're not really doing much of anything here. The only thing that's somewhat node is that we have to pull parse5 out into the node modules. So that's it. It doesn't bundle well. All right, let's take a look at the actual stack itself. So if we back off to the stack itself, we're going to skip down to the bottom. Hopefully the mic is better, but we're going to skip down to the bottom. We have the API here. So the thing I had mentioned before about a functional web app, we're going to make a route to / the top level route, and it's just going to call this handler. And the responsibility of this handler is to give back some HTML. The other trick to this is this proxy that's going on here. So in order to have a server-side rendered app like this, we need to have our components on the server and on the client, right? If we want client-side hydration, which is what we're talking about here. So on the server side, the server needs to be able to render this stuff. And on the client side, the client needs to be able to get access to our lit components to be able to hydrate it. So what we're doing here is we're just making a real simple route. And this comes from arc.codes. I'm actually just borrowing their syntax. This is pre-existing pattern. Any client request to _static and then anything is just going to get proxied through to an S3 bucket, right? So our main URL will go here. Any of our other assets that are static will get proxied through to an S3 bucket. You can really quick look at the bucket up here. It's just a real simple bucket with public read access, just like you'd set up for any other kind of web served bucket. And then down here, we just have a deployment for that bucket where we're just grabbing all of the assets in some path on my computer, and we're gonna toss them up into that S3 bucket. All right, moving on, let's take a look at the code itself. So the Lambda itself, this is that root path. You can kind of skip over this. This is just a way to turn a stream into a promise. The Lit Lab server-side rendering library returns back a stream. I think they're kind of going long-term with HTML streaming back from the server. So here we just get that render function from that. And then in our handler, we simply, I'm grabbing some query parameters just so we can do some templating. And I'm going to render this template, right? I'm going to grab this function, pass in some stuff. The result of that is going to be converted to a stream, and then we are going to convert that into some body text that we can actually see. Let's take a look at the template really quick. It's just a exported function that takes whatever is going to templatize. Whoa.
Yeah, sorry about that. Your slides are showing, not the screen. It just flipped for a second.
This is a disaster. All right, back to code. Did it just do it? I hope it just did it. So, all right. Well, anyway, here's the function. You guys were just looking at that awesome image of Back to the Future. I wonder, that's fantastic. That's fantastic. Anyway, this template function will take some properties that are needed to template, and it will return some lit-based HTML. We'll talk a little about why we're using import maps up here. But the main thing to know is that we literally just have a lit element here in the body, right? That's it. All right, that's it. That's all we got. And it gets, we don't even, you notice like we don't even like import it or mention it. That's because the way that the lit server-side renderer works is by just importing a component, it's going to get registered in this global space so that when we use it in this HTML on the server, this will all actually get rendered out just fine. I'll quickly show these. These are just regular old lit elements. If you don't know a bunch about lit, go check it out. Here's all it's just really basic. We just have an app and then a clicker that's going to keep track of its own state every time you click on it to count up. Really, really basic. The idea here is that that app needs to be rendered on the server and then hydrated on the client so that we can get interactivity, so we can get live interactivity. All right, let's run it. Let's run it and see what happens. So this is just me running, SST start. All of this should be deployed, so we'll get this up here. Trying to think if there's anything else of interest to mention here while it's coming up. I don't think so. So then we will switch over here, and I will go here and refresh this page, hopefully. Not ready yet. Here. This is it. There we go. Cool. So this is our app running in local Lambda dev. Obviously, if I click on it, there's nothing there. And if I open up the network panel and refresh this, you'll see it's just making one request. But all of this lit stuff was rendered on the server side, right? Nothing fancy was happening here. And then if we go back into our template and we uncomment these two lines, which is going to import the hydration support for lit and then import this my app component from the client side, right? So we're going to import that from the client side. So we'll just save that, switch back over, we'll reload, and you'll see all that stuff gets loaded up in here. And when I click, it's hydrated. App has interactivity now. That's simple, right? That's simple. The last thing to talk about, the little trick that's going on here that I'd love to see, turned into like a simpler construct here is this proxy pattern. So in local dev, when we set up this proxy path, we're just passing everything onto this proxy handler. And that's just doing a real simple like read file from my local system and passing it along. However, when we switch this over and we go to production, this actually gets past the S3 bucket. So there's no processing. This is static files are on S3, dynamic files are called in a function as is intended in the world, and all is happy. And I think that's pretty much it. I mean, I have a bunch of other stuff to show you, but I think we're pretty much out of time on that. So I think that's it. I hope you guys got to see some of it, and thanks for checking this out. Hope you liked it.
Awesome. Yeah, thanks for sharing that, Ross. Yeah, SSR is something that we definitely want to support more natively in SST. It should be really easy to deploy a regional or even edge API that's doing SSR, and it's a focus of ours. So it's cool to see early steps towards that. All right, so next up, we've got Boris. Boris is actually one of the first people I met when I joined the serverless community. It's probably around a year ago. He's the founder and CEO of Baselime, where they're building an observability solution for teams building with serverless.
Hello, can you share my slides as well? Awesome, thank you very much. Hi everyone, I'm Boris. I'm the founder and CEO of Baselime. We are building observability for serverless, and today I actually want to tell you more about how we do transactional Outbox pattern on AWS. That probably means nothing to you right now, but we will see exactly what it is. So we are all going serverless, and when we go serverless, the idea, generally speaking, is to also adopt event-driven architectures. So this is what a typical, application will look like. We have an API gateway where a user can make a request. There is a Lambda function attached to that API gateway, processing the request, writing into a DynamoDB table, the state of the application. And we have this messaging piece, which usually sends events to other services such that they can consume them. So if you take an example, a user makes an order on a e-commerce website. The first Lambda function will write into the projections table, and when an order is made, and then all those other consumers will be, for example, sending an email to the user confirming that the order was placed appropriately, and also another Lambda function for the fulfillment service, etc., etc. But this architecture has some very interesting challenges. First of all, we need to make sure that services must atomically update the database and send messages. We don't want to be in a position where we basically get a new order, write it into the table that an order was placed, but we never actually send the event to other services to fulfill that order, for example. So that can happen in multiple scenarios. For example, the Lambda times out before we are able to send the message to downstream services. And the other thing that we want is to make sure that services should offer a journal of events that can be replayed for rebuilding or refreshing the state. So this simply means that when we have this really beautiful event-driven architecture, things wrong. One service can stop working for whatever reason. There might be a bug in there. And we need to be able to refresh that state after the bug is fixed. And the way to do that is to have a journal of all the events that happened into every service, so all the orders that were placed, for example, and then we can simply replay those orders that were placed, and the state of the downstream services should be updated accordingly. And the transactional Outbox pattern is basically a solution to these two main issues that we have. So this is an example based on a SQL database, a MySQL database. Basically, the way it works is when we get a new order, we have two tables in the database. We have the order table where we write the orders, but we also have an Outbox table where we write the event saying that the order was placed. So that event will have all the details about that order. And we have a message relay service, which is basically continuously polling the Outbox table and then sending that to the message broker. If we write into the database using transactions, the MySQL database using transactions, we make sure that we cannot have an order written without the event for that order being written. Now, this is all great, but it's based on MySQL technologies. We know that right now, SQL databases with serverless don't work too well together. So at Baselime, we actually adapted this pattern onto a serverless architecture. The way we did this is replacing the MySQL piece with a DynamoDB table, a Lambda function, and event bridge. So basically what happens is when a user makes a request to create a new order, we take that order, we write it in the projection table as usual, but concurrently, we also write into the internal event store. That internal event store is a DynamoDB table taking the events, and then we have the streams from the table, which are then being processed by a Lambda function, basically adding things like the service that it comes from, and then pushing that event into EventBridge, which is going to fan it out to downstream services. So how does that work in code? Basically, we get the order, we create the order with all the details about it. We also create an event with type order created. We get the timestamp, the time at which the event was processed. And we add the ID, which is basically the ID of the order. And when we write into DynamoDB, we can write in the two tables concurrently using DynamoDB transact write function. That will then allow us to make sure that we never write into any of the tables without writing into the other. And then the way it works is, this is basically the schema for our internal event. We have the ID, as I mentioned. We want to be able to get all of the events for a specific order. Let's say we have order created, order updated, and order deleted. All of these events will have the same ID, so we can query this internal table with that ID, but we also have the type, which will allow us to get, for example, all the events for creating an order, basically. And in SST, the way we implement this is creating the table using the SST construct, but we make sure that our partition key is basically the ID and our sort key is the timestamp, such that we can have all of the events for a particular order, for a particular aggregate ordered by timestamp. And we also add a global index, a global secondary index. And for the partition key there, we use the type of the event such that we can get all the events from the same type. And the sort key is still the timestamp. What is very interesting is that we then have the stream on the table, and we can use that stream to have a consumer directly attached to it. And then the stream processing is basically a Lambda function that then fans it out to EventBridge. So the outcomes is basically, now we are guaranteed that all the messages will be sent if and only if the DynamoDB transaction commits. We also abstract all the implementation details of our internal messaging architecture from any service. So the services don't need to know that it's EventBridge or SQS or SNS or Kinesis. It simply knows, I get an order, I write it into the database, into the tables, that's it. There are other functions that are responsible for fanning it out to the downstream services. And we keep that source of truth of past events, and they stay within the service, because this internal events table stays with the service. It's not shared with other services. But there are drawbacks with almost everything in software. We have additional latency because transact write items is considerably slower than put item. So our request is going to be 2 to 3 times slower because we have these transact write items compared to just writing with put item into the projections table. And it's also error prone because if we are not careful, developers can forget to write into the second table, the events table, when there is a new operation being done on any aggregate. So basically, this is a summary of how we do a transactional Outbox pattern at Baselime. Thank you very much for having me. I don't know if you can ask questions if you have any, but that's it. Thank you very much.
Awesome. Yeah, that's a really cool pattern. It's the exact same thing that I do myself. It's really handy if you don't have this in your code base, put it in there. You're going to find a bunch of use cases for it. Cool. All right. So our next talk is from Tamara. She's the founding engineer at Acre and has over 10 years of experience working at companies like OpenTable and Red Hat.
Hi, good morning, Serverless Stack. Really excited to be here. My name is Tamara Dottin, and I'm a lead software engineer with Acre. Acre is a venture-backed early-stage company that is fundamentally redesigning home ownership, starting with a more flexible way for people to purchase their home that takes the best of both worlds from renting and a traditional mortgage. We built our V1 from the very get-go using Serverless Stack, or SST, and we couldn't be more pleased with how quickly it allowed us to get to that high-quality V1 product that we could start iterating on with real-life customers. There are several ways in which SST helped to make our lives easier, But what I want to highlight today is the way in which it helped us to manage and orchestrate our environments all the way from development through to prod. So as a small but experienced team, we had a lot of strong opinions on what we wanted the environments to look like in our development lifecycle process. First and foremost, we wanted each of our environments, especially in development and testing, to be as full-fledged and production-like as possible. When building serverless applications, there are a lot of options out there for local simulators for cloud-based resources. We wanted to avoid relying on these because oftentimes there are subtle differences between how real AWS resources actually work, and this can cause a lot of brittleness, especially in those development and testing environments. Our second goal was that we prioritize the safety, security, and consistency across our resources in the environments. We wanted strong isolation for side-by-side resources, even when those environments were operating in the same AWS account. And being a fast-moving team with some pretty aggressive goals, we didn't want to risk our developers accidentally impacting or even clobbering resources that are in another person's environment. In terms of consistency, we also didn't want to fall into the trap where something that works for one developer in their environment doesn't work for another. Lastly, knowing our ambitions to scale and grow the team and add really high quality engineers to the mix, we wanted to provide a top-notch developer experience. And we didn't want the management and orchestration of these environments to become a burden for our developers. We are still early and don't have a dedicated DevOps resource. So we had to make sure that implementing and deploying to these environments didn't detract from the really important product and feature work that had to get done. Let's take a look at the topology for our environments. The first layer that you see here are standing developer environments, and these are deployed to their own isolated AWS accounts, one for each developer on the team. We also have in this layer the need for more temporary one-off environments that we deploy either for testing a spike or maybe a long-running feature that a developer needs to collaborate on with somebody else. So in those instances, those are deployed to the same AWS account, and they need to be able to run their resources side by side without impacting each other. The next layer that we have is for our testing integration environments. So these all live side by side in an AWS account together. These environments actually leverage some shared resources between each other. Specifically, we deploy one VPC for the environments, and it contains a database cluster. And each testing environment has its own database within that cluster. So we'll talk about how SST helps us to manage those shared resources across our environments. After that, we have our traditional pre-production or staging environment and production environment. Those as well deployed to their own AWS accounts. So how do we go about leveraging SST to achieve all of those different environments that I just spoke about? First and foremost, we use the out-of-the-box configuration support that comes built in with SST. SST uses the notion of stages to distinguish one environment from another. So when we're deploying to a stage, let's say dev, SST prefixes all of the resources with the name of the application and the name of the stage so that they will not clash with each other, even when running side by side in the same AWS account. So this really comes in handy for us for those development environments or those temporary one-off environments that we're deploying for a specific dev or bug fix or feature. Really, really easy to manage just by switching out the stage name that we're using. SST also comes with built-in .env support. And so this allows us to layer in configuration for our different environments. We can use a default configuration across all of the environments and then define environment variables that are specific to a given stage. Using this in conjunction with AWS's Systems Management Parameter Store really allows us to get some granular definition around our environments, all deploying them within the same manner. Lastly, SST also comes with a script construct. And so this is one-off code that you could run upon deployment, either on the first creation of a stack or whenever a stack is being updated. And so we leverage this for seeding our databases and doing different seed configurations for the development environments versus the testing environments versus any one-off environments that need a specific configuration around the seed data. The second way in which SST helps us to build out our environments at Acre is with its live Lambda development functionality. So as I'm sure you'll hear from several speakers today, this is really a game-changing feature for SST. In our development environments, it allows us to move really quickly by proxying any requests that are made from AWS resources to our local Lambda code environment. And so any changes or updates that we make are automatically detected, built, and reloaded. So we get that real-time feedback for any edits that we're making. We're also able to set breakpoints, which really help to speed up debugging in that development environment. So this goes a long way to deliver on that top-notch developer experience that we wanted to afford our team, even though we were building out serverless applications. The third way in which SST supports our environments is through giving us the flexibility to create very modular stacks that allow us to define and reuse any shared resources. So as I mentioned, with our testing integration environments, there are some shared resources with the VPC and its database cluster that each of our environments need to reference within their stacks. So for this, we can use SST to take a more modular approach for defining shared resources. So we keep those isolated to their own stack that we could deploy separately. And then whenever deploying our testing integration environments, we can leverage AWS CDK's import functionality so that it can find and import the existing VPC or database cluster that we want to reuse. Because we are working natively in our language of choice, which is TypeScript for our team, we are able to define a lot of this conditional logic based on the environments a lot more easily than if we were working out of YAML or any other configuration files that are pretty common with infrastructure as code. We can even write just unit tests for our stacks just to give us further confidence as we continue to maintain and grow these environments that they are configured as we need them to be. Looking ahead, we're really excited about a lot of the continued innovation happening with serverless stack, especially around the concept of functional stacks, which will ultimately make sharing resources and these modular environments a lot simpler to manage. Having prod-like environments that you could easily spin up and down for development, testing, feature acceptance, and more is a huge win for teams, especially those that are fast-paced in developing really high-quality products. I appreciate the time here. Hope you all learned a little bit more about managing your environments with serverless stack, and enjoy the rest of the conference.
Awesome. It's really cool to see how Tamara's team is using SST. I don't think she's really, her team has really talked to us about or asked us questions about how to set all this up. So their team came up with all this on their own. So it's really cool to see these advanced organized patterns emerging from the teams that are using SST. So our final speaker before the intermission is Kevin. He's currently a principal platform engine architect at Analog Devices and has over 20 years of experience working across video, IoT, and general SaaS platforms.
So this is a Speedy Services with Golang and SST talk. We want to show how we're going to be using Golang with SST to provide significant performance and cost benefits for Lambda projects. My name is Kevin Baker. I'm a principal platform architect with Analog Devices. So I handle architecture, engineering, and then I manage a team here at Analog. So we're building hardware simulations and then product discovery applications for our customers. So these are either heavy compute or sometimes data services where we're hitting databases for search data, as well as storing files and recovering them. Our primary architectural requirements are better developer experience as well as better performance. Most of this talk is focused on the performance side of things, but just touching on better developer experience. This is why we chose a serverless stack, right? So normally we have a flow like this where you're working on a local Lambda. In order to really test and evaluate your code, you actually need to deploy it up to the cloud, and you have to wait for that deployment. So the iterative cycle is actually pretty slow. So with SST, we're able to introduce serverless stack in here and actually work locally and have instant evaluation of our code. The main thing here for us is better performance. So Lambda is priced on the number of executions, the memory size of your Lambda deployment, and then the duration of execution. So we're focused on optimizing the duration of execution using faster programming languages. So what are your options? We looked at JavaScript, Python, Rust, and Go. What we found is if you go to a lot of benchmarking data, as well as some of the POCs we ran, you find that in general that JavaScript and Python are considerably slower than both Go and Rust. Go and Rust both would be great options when you're looking at optimizing performance. We actually decided to go with Golang here, mostly it's performant, has very fast cold starts. It seems to be easier to learn than Rust, at least for our team. And it has really great growing adoption for sort of SDKs out there, particularly with AWS. So project structure is pretty important when you're attacking a project like this. We need to combine SST with Golang. How do you do that? So a typical serverless stack project looks something like this. Often people are using a source directory instead of this backend one, but this is a common pattern coming out. A typical Golang application looks like this, right? You have a command folder. This is your compiled binaries that actually get run. You have an internal folder. This is your private application code. And then if you have any public libraries that you're open to sharing with other projects, you can actually dump them in this package folder. And then you have a Go mod file. That's just like your package JSON file. So what does it look like? We just take the typical Golang structure and we dump it in our backend folder. That's kind of how we're building our projects. Okay, so this is an example project I pulled together. It is SST Golang project. So this looks like a normal SST project, right? We have a backend folder in here. This contains the Go code. We have a main module. Within the main module, we have command, internal, and package folders. This is pretty standard Go stuff. So the internal folder is for our private application code. We organize our projects into controllers and services. Controller aggregates data. Service is responsible for data requests. So I'm just going to go into this plot data service here. So this has a get data method on it that takes a sample rate argument. And then we just generate our data down here based on the arguments for the data set. This thing is called by a data controller, right? So I have it right here, plot data controller. I'm also handling a Fibonacci service request as well, just to show an example of a second service. And this is actually sending back the data. So the sent back data is actually in Go structures at this point, but we want to actually format them for a RESTful call. So we have our handler. In the command folder, we build our handlers, which are actually compiled code. And so this example here shows us calling our data controller. that we just went through. We call the get data method on it. And now, since we're formatting this for a REST call, we are marshalling and sending a JSON response. This handler is set up in the stack. So just like any other SST project, you define a stack. Our route is actually calling Go files here, though, instead of JavaScript or Python or whatever you're using. So we're calling inside our command folder, command handler example main Go. So the way that looks is we have Postman here with our deployed code up in Amazon. And when I call this, I get my Fibonacci sequence, and then I get a whole bunch of crazy data in my data set based on my parameters up here. So our projects generally are for visualizing data. So I just took that same controller and I made a little command line utility with it. And what you get is that same data pumped into, in our case, this GNU plot program, and it will plot that data out. So this is the same data we're getting from the REST request pumped into GNU plot, and you end up with a visualization. Okay, so final thoughts on this. I think it's really good to consider programming languages like Golang as an option when you're developing lambdas, and it seems to work really well with SST. TypeScript's great. We love TypeScript, and we definitely still use it for a lot of projects. But when we're thinking about performance, I think it's really good to look at other options. We settled on Golang, but you might find something else that works better for your team. Golang is very fast, and because of that, we get performance improvements. In the cloud, you pay for what you use. So if your applications are faster, your costs generally will go down. So performance really does matter. Thank you. This has been a talk about Speedy SST with Golang. Please feel free to take a look at the example code and reach out to me if you'd like. Thank you.
Awesome. Yeah, Kevin makes a great point about sprinkling in Golang when you need performance. Even with the SST code base, there's parts of it where we've played with implementing it in Golang, and we've seen a lot of performance benefits. All right, so from here, we're going to take a quick 10-minute break to give everyone a chance to stretch their legs. If you want to stick around, we will be answering some questions from YouTube and our Slack channel live, and I'm going to bring on the rest of the team to do that now. I think Jay's got some questions.
Hey everybody. Yeah, just put some of your questions in Slack or in YouTube. I think the one common one everybody seems to be having is, are these talks going to be recorded? Yeah, they will be. We'll upload them after the conference. And let me just go through and see if you guys have something here. We had a few sent to us before, so maybe I'll just sort of start with that. Frank, I think one common question we get quite a bit is about how does SST sort of compare to the other sort of frameworks out there for building serverless? You know, serverless framework, CDK in itself, SAM, and so on. So if you could, sort of talk to that a bit.
Yeah. I think there's like two ways where you want to look at this. One is, the way I tend to look at this, if you just put yourself in like a developer shoes and think of, today I'm going to, with my team, we're going to work on an app, and what are the steps that are involved? And there is, obvious local development. How do I, what database should I use? How should I set that up? How should I run the migrations? How should I deploy my code? And as I'm working, like, how do I manage my app as I'm working on it? I guess the AWS console, it's a default go-to place for that. And then after my app, it's built, how do I plug, analytics into it? How do I plug, data warehouse into it? Once you go to prod, how do I monitor it? I think if you look at this entire dev workflow for building out an app, I think most of the frameworks, they help with the very initial step. And once you step out of the comfort zone for framework, you're on your own. And so the way I kind of want to look at SST is I don't want to stop there. We want to, kind of like I mentioned in the keynote, where we want to look at one problem at a time and solve that for developers. That's why the first one we solved was live lambda development, which solves the the local development, the slowness issue. But then now we want to move more upstream. We want to provide more better guidelines or best practices on how you should build out larger pieces like the GraphQL stack, the entire backend that Dax will talk about. So yeah, so I think SST, the way we want to look at it is we want the framework to be able to help you from the day you start till you go IPO, where all the framework kind of grow with you, with all the feature sets and everything. Yeah.
Right, and I think this is something that we'll probably touch on, both in sort of Dax's demo and talk a little bit when we look at sort of the future of or the next phase of development for SST, and I'll probably touch on it a little bit in some of my closing remarks as well. Dax, I think I've got one for you. There is this one question that we've gotten sort of recently specifically with the V1 release where we put out functional stacks. And I think, just from sort of an outsider's perspective, if you just looked at functional stacks, you would go, oh, this is sort of syntactic sugar, like why sort of do this? And I think this might be sort of a good opportunity for you to maybe talk to that, because, you built it yourself and you came up with the idea for it as well.
Yeah, so I think the idea for functional stacks started in a specific place, which was we just get a lot of questions around sharing resources between stacks. And to be honest, every time I answer that question, I would kind of answer it differently. Like sometimes I would pass the entire stack to another stack. Sometimes I would pass a specific resource. And it never felt quite right. So I was trying to think, okay, if ground up we were to build this and we ignored any of the existing patterns, what would we come up with? The thing that I discovered in that process was the old method also doesn't support TypeScript really well. So my opinion is if libraries are built well, if TypeScript libraries are built well, the end user of that library shouldn't really have to be importing types or writing too many type definitions in their code base. With the class-based stacks, there was a lot of type definitions you had to import. Like if you wanted to export any resource, you had to now figure out what type that was and where the interface for that was located and import that. So one of the constraints I wanted to introduce was, okay, how can we make it so you never have to do that? You just mark resources as to be shared and you can import them and get the proper types without being explicit anywhere. So that's kind of what led to functional stacks. It's a pattern that allows for, us on the SST side to do inference for you. So when you're sharing resources between stacks, you get strongly typed results right there. You don't really have to think about it. If you look at our code examples now, the JavaScript version of our code example and the TypeScript version of the code example, it's like 99% the same. And before it was fairly different. So I think whenever that convergence happens, it's good, and you should shoot for designs that make that happen.
Yeah, that makes sense. And I think this is something that we should probably talk a bit more about, in detail. There are obviously a few tweets here and there that Dax sends out from time to time about this, but I think it's worth sort of expanding on. We've got a few more questions sort of coming in. I'm going to pick one of the a really sort of simple one, but obviously something that speaks to the whole V1 release. And there's a question here on the YouTube side. What is the difference between 0.x and 1.x? Is 1.x stable now and can be used? I don't know, Frank, maybe you want to take that on?
Yeah, I think from stability side of view, it's 1.0 is totally stable. It's more of a syntax change. I think one of there are a couple things we're to build in this V1. One of the things we should focus on is it's actually this feedback given by Luke. He's going to give a talk about how they're using SST at Lego. And it's a feedback they brought up where, as someone who's new to AWS, they having to pick up both SST and CDK at the same time. So one of the big initiative for SST V1 is to give people like a progressive learning ramp, so that they just have to learn SST without knowing what CDK and the underlying CloudFormation resources are, and give them a buffer where they will have their APIs and stacks up and deployed. And if they want to go in and further customize it, they can jump in deeper. And there's a clear line between, hey, you're now stepping into the underlying resources. So just to make that differentiation. Yeah, that's the most change for V1. And V1 stable and folks are using it in production.
Yeah. I mean, that's really just it. It was more that there are a few things that we noticed with the 0.x releases that we wanted to address, but it required some changes on how the constructs on the APIs for the constructs themselves. Dax, I think you might have noticed this one. This is in the Slack channel, but it's talking about monorepo and SST projects. I don't know if you want to take that one on.
Yeah, let me look at the question real quick. Yeah, so the question is, how do you see working with a monorepo? Is it something that's recommended? And how do you avoid the problem of multiple deploys of all stacks in one monorepo? So I highly recommend starting off with a monorepo, put everything in one place, especially at the beginning of a project. The boundaries really aren't clear, and they're going to shift a lot. As clear as it might seem on day one, it probably isn't. So in terms of avoiding the multiple deploys of all the stacks, so this may be a little confusing, but the process of deploying, it actually occurs in a few steps. There's a synthesize step, which happens outside AWS in terms of like it doesn't touch any AWS resources. It basically looks at all your stack code and synthesizes a CloudFormation template out of it. In this process, we'll do things like build the functions that you need, build the static sites you need, figure out how everything plugs together, figure out what stacks export things. That process will apply to your whole code base. So the bigger your code base gets, that process probably will slow down, but it generally is pretty fast. Then for deployment, it doesn't deploy all the stacks. Once it's synthesized a CloudFormation, it can tell what actually has changed and what needs to be deployed. So it's not deploying every single resource in your stack. It's shipping that CloudFormation to AWS. AWS is figuring out what's changed and only deploying the diffs. So the actual deployment part shouldn't slow down as your app grows. I do recommend building very granular stacks, and this is a lot easier with the new functional stacks concept. The smaller your stacks are, the less work that AWS has to do because it diffs per stack. For the first part, the synthesize step, admittedly, that does get slower as your project gets bigger. We have some plans for the way CDK is currently built. It does everything serially, synchronously. So we have some plans to do things like defer function builds during the synthesize step and then build them all once in parallel at the end. That should make it so the time there isn't increasing linearly. And we have some people that, I think yesterday I was talking to someone that had 133 functions or something, and improvements like that will make a huge difference on deployment time for them.
Yeah. We're coming up on time here, but I'm going to take a couple more. We've got one, and this is a very common one that we get, and I think, Frank, this might be a good one for you. Can you talk about, and seeing this on YouTube, can you talk about how native CDK constructs work within serverless stack, especially the CloudFormation stack perspective? Is it identical to CDK?
Yeah, it's first of all, SST is really built on top of CDK, and there are three key concepts we have in SST were introduced on top of CDK. One is an app, a stack, and a function. An app an app is pretty much similar to the CDK app. It just extends that class. Same as stack, it also extends a class, except that the app and stack is aware of what stage I'm in. So it will do a bunch of checks where if you forget to parameterize your stack name by the stage ID, meaning that kind of like what Tamara has mentioned, if you deploy two different stages into the same account, and if you don't parameterize the stack name, you're gonna get stack name thrashing. So we're just doing a bunch of checks out of the box by inheriting the CDK app and stack. And the SST function is also inherit of CDK function with the added benefit of live Lambda development, so that when you run SST deploy, it's a straight up Lambda function. But if you run SST start to start a local environment, it deploys a stub code that's able to proxy the request to your local. So I'd say stick with those three constructs. For everything else, you can use whatever CDK construct you come across. Just that when you write in, whenever you use the CDK function, replace that with the SST function to get the live Lambda dev experience. But apart from that, any CDK construct can be used directly in the SST.
Yeah. We're almost on time here. I had one more question. This was from Omi from from a little bit. But I see we've got a couple other questions that are coming in. What we'll do is we'll stick around, after the stream ends, and we'll answer these questions in Slack itself. But before we kick back with the talks, so Omi's question was, how does a team organize all the things you work on between Slack, medium-sized features, and long-term projects? Dax's answer was that we don't. We do it very poorly. But to give more color to this, and this is something that I'll talk about in my closing remarks, but essentially, there's a sort of a core concept behind the way we work, and this is maybe something that I want to try and share with the community. When I think about this conference as a whole, this is an opportunity for us to almost, sort of put faces and sort of conversations, I guess, to these sort of Slack conversations that we have, right? And so with respect to the specific question, I might not be able to directly sort of answer it, but I think I'll have something to share about, why we're working on what we're working on, what we're trying to do. But yeah, so thanks for all the questions. With that, I think we'll sort of I'll hand it over to Frank, and I think he'll take us through the second half of SST 1.0 Conf.
All right, welcome back, everyone. To get things started, we have Zach from Comcast. He works on the NGAN team at Comcast, mainly developing service applications for managing, monitoring, and testing Comcast network infrastructure. And previous to that, he is in the theater industry doing audio engineering and sound design. All right, Zach.
Hey, everyone. I'm so glad to be here today. Thank you for the introduction, Frank. So today I'm going to be talking about simplifying step functions. And that's kind of a smaller byproduct of what I'm going to be talking about, which is just the incredible, better developer experience you get through SST, and we'll go through that. First, I'm going to give some business context of what we're using SST for. We have a test. It's called IHAT, In-Home Assessment Test, and we use this to basically we run custom modems within the Comcast network on modems, and maybe if you have Comcast, it's on your modem to determine eligibility for something called mid-split. Mid-split is a configuration for the modem / node. We'll get to what the node is and /RPD later, but it allows us to expand the upstream spectrum, increase your upload speeds basically. But this can have unintended consequences by interfering with your set-top box if you have one and your picture quality. So we run a test to ensure that doesn't happen if we are going to move to change the modem's configuration to mid-split. Basically, how this works is a node distributes to many customers, and in each customer's house, there's one customer or whatever household, and they have a modem. And set-top box says could be none, could be multiple, and that'll come in handy later. So that's a basic premise. So how this works is we get devices on each node. We create jobs for each device / set-top box pair. We call it a job. And then we pass it this step function to collect device information, run the test, and then determine the results. This requires a lot of external resources, so the retries and error handling within step functions is really handy for this. And then at the end, we determine pass, fail, and if there's an error, what to do with that device. Do we try to run the test later, see if that works then? Do we just put it in something called the penalty box to make sure it doesn't get run because we don't think it'll be compatible with mid-split. And that's kind of the basic context. It's a lot more complicated than this, but this is the simple view. So this brings us to our problems. We've been developing, IHAP for over about a year now, and we started with serverless framework. The problem with this is our infrastructure was declared in YAML files. Oh my gosh, trying to write step functions in YAML file, it's insanity. There's no tight safety, and you have to get the indentation right, and there's no way to do it well. It's just overall frustrating, and passing references, you have to it's a nightmare. So that's one thing. Additionally, we had multiple developers testing and deploying individual lambdas in dev because you have the step functions in the cloud, and the step function has a bunch of lambdas, and developer wants to say, hey, I'm working on this lambda, let's see what happens. And then you try to run a test and your test fails because they have some different feature that they're working on. This is always a problem, and you'll see a thread, multiple developers affecting the mocks and mock database at the same time, which is just another issue because we have our mock services which are deployed separately from our main stack. Additionally, multiple developers using the same set function as SQSQ at the same time. You had to purge queues if other people had ran things, and maybe their what they were trying to use failed, and SQSQ gets bugged up. It's a big pain. Iteration time. If you want to run another step function, like run another execution, and you need to change thing in one of your lambdas, you have to deploy it. It takes a while to go through the deploy process, and that iteration time is severely painful. Additionally, chasing Lambda logs through AWS console. I mean, you could just click the Lambda logs link, but it takes like 2 seconds, and I'm impatient, and that just is, for me, unacceptable. So that's a little bit of a pain point there too. And also retriggering Lambdas with the inputs. So, there's a lot of copying, pasting of JSON, and then you can't run in the right context because it needs to be in the context of the state machine. You can't run the Lambda by itself. That's another pain point that we experienced. So we attempted some solutions. Our first attempt was local stack. You might be familiar. The only issue with local stack is that they didn't have all the services that we were using with AWS, like layers, some certain step function resources, like the default step function resources they didn't have, and so that was a no-go. Step functions local, but then you have to download, like you have to pay for Docker, which is not ideal either, and it's also kind of a larger barrier of entry for each developer who wants to use it. And the third option was just embracing developer despair, which, I mean, it's not ideal. I mean, this is fine, right? This is fine. Just, I don't know, am I holding the coffee cup? I can't really see it. It's kind of hard to see. But, that was the other alternative, which I don't think is a good alternative. And it really felt like that until my manager Zen sent me the serverless stack link, and that's where things got a lot better. It solved a lot of these issues. I mean, you could solve a lot of these issues by using CDK, but serverless stack does so much more than what it's capable of. First of all, the SST constructs, type safety via TypeScript and IDE suggestions that they added is incredible. And in addition to the familiarity with Node, all of our developers know it for the most part, versus like trying to write something in YAML is just a night and day difference. Unique environment for each developer. So each developer has their own databases, their own SQSQs, their own step functions to run, and we're not stepping on each other's toes. It's really incredible to have. Additionally, the SST console is great. It's so awesome to have all of your everything you need in one view. So I'm just going to keep track of time. And I'll go into that later when I run through a live demo. It's easy to make sense of the inputs and outputs of step functions when you're seeing them in the console itself. You can run the entire workflow independently. This kind of ties to what I said above. And using the debugger, you pause during the execution of your step function for each step. If you want to hit the Lambda and see what's happening, and having an insight into your actual Lambda function is huge. And like I said, SST contracts can remove a large amount of boilerplate, like having SQSQs that you can define a consumer, and it just handled. You don't have to worry about how you're associating the SQSQ and the consumer. It's just great using the SST constructs. And that brings me to the SST superpowers. We kind of touched on these, but like I said, debugging lambdas from your local is incredible. Oh my gosh. I've definitely pushed SST to its limits, where I've run huge tests, and my local's been able to handle it. SST has been able to handle it. hundreds of devices, and I could still, eke along through a step function execution with it, hitting my computer for all the lambdas. Additionally, all the support from the SST team, they're so amazing. When I first started, I was running into a lot of issues trying to work within my governance for Comcast in a big enterprise, and they stepped in and were incredible and helped me figure out my issues, implementing new features to let me, get my development going. It was amazing. That's one of the coolest things. Additionally, the CDK escape hatch. If you're worried about anything, you could always, and I do this for the step functions, you can always escape out of the SST realm and go into use normal CDK, AWS CDK, and that's great. Like I said, the SST console is incredible. We'll touch that in just a second. And the SST constructs. These are all really good reasons, and there's so much more that they're working on to make use of SST in your development. So now it's live demo time. Let's go. Give me a second to move over there. So let's do this. Alrighty. So we have, let's see, I'm just going to trigger this. All right. So like I said, this SST console is great. What I'm going to do is I'm going to run a mock test here. This is what I'm talking about. If I want to retrigger this, I can just copy, paste it. It's lovely. It's easy. I'm going to do one device, one modem, and this should be a successful job. What happens when I invoke this? It's going to trigger a long, complex step function that has many steps, and I'll try to step through them all. We don't have tons of time, but hopefully we'd see a little bit of this execution. So I'm going to invoke this here. And if I go to my, let's see. So the first thing it's going to go to is this generate jobs workflow, and you see the step is running currently. And this is the current job that got processed. So it generates the job that we have, has the model, all the information we need in order to run the test. What's great is that while this is happening, I can go here and, sorry, hold on a second. Let me update this. Yes, okay, here we go. Sorry, wrong window. You can see the request that I just made, and you can see all the logs right here in this window, which is incredible. And I can also see the direct response of this right here in the console. Additionally, while this is all happening, we have our mock APIs down here. And at any time, I can scroll down and go see what's happening within our mocks and see what responses and requests I'm getting as my step function is making requests to this. So let's go back to the step function. And so after generate jobs, it gets sent to the main workflow. This is our main workflow. So after we generate the job, it gets sent to this state machine, which we first see if the modem's online. We check if it's in something called the penalty box. That we put that in there if we think the modem should not be tested. We initialize the job task itself. We actually add it to the database, and we then send it to the prepare step function. And this has already all happened because it moves pretty quickly doing one modem. And this is where we collect all the device information. We do some checks to make sure that it's in the right configuration that we require it to be. If there are any errors, it will fall down here, and it'll be returned at the end. In this case, it succeeded all of our checks and goes to the next step in our main function, which is disposition. And disposition is a choice, step function choice, that's going to decide what to do with this modem depending on what happened in the prepare step. If this fails at any time, it's going to go through any of these other avenues. But in this case, it logged past and says no more retries and ends the execution. There's so much more going on outside of these two. There's also the actual testing, testing step function, which actually tests the device. And as you see, I'm clicking through all this, but the huge benefit here is when you're running through this many times and trying to debug things, I can click through these different stacks instead of going through this view and having to click through the console and going down here and open the CloudWatch logs, which takes like a second, like I said. Instead of all that, I can just go directly to each Lambda that's been run. Sorry, wrong window again. Directly to each Lambda that's been run and see exactly what's happening on the inside of all these requests. And I can also replay these right here, right now with the same request, and I can go change them. Okay, yeah, so this is going to happen because of I tried running a device that probably is deleted from the database now. But this is a good way to get a good view of what's going on inside your step functions really quickly, really efficiently. Additionally, what I'm not touching on right now is the fact that I had to remove the RDS database because of a conflict between my environment and our true prod environment. But if I had my databases set up, you could go right here and query your databases right here from this window as well, which is also really great. SST console is obviously amazing. I'm super psyched about it. I highly recommend checking it out for you. It's been a really incredible experience to work with for me. And that's kind of it. I know I went a little bit over, but it's a lot to fit in. But thank you so much for your time. I'm so glad to be here, and yeah, enjoy the rest of the conference.
Thanks, Zach. You know, when Zach first showed me the first version of his demo and having the VG Studio spin up, I'm triggering a step function, and that all of a sudden spawned 20 or 30 node process on his local machine to run different steps from various step functions. I was kind of nervous. I'm like, hey, Dax, I'm not sure if this demo is going to go well, but I'm glad it went well. And I take back a feedback from us would be we really need to build out a step function explorer in our SST console. That could make the life so much easier. All right, with that, up next we have Dax. Dax joined us back in August, and since then he's been instrumental in rewriting SST and getting us ready for view and release. Many of you in the community might know Dax as for his love for taking TypeScript so far. And in his talk, he's going to give us a sneak peek into the next phase of SST.
All right. So really excited to give you guys all a preview of what's coming up with SST. So in this talk, I'll be going over the GraphQL stack. This is going to be the next phase for SST. So far we've given you primitives to build infrastructure, but we haven't really given you much on the application side, and the GraphQL stack is the first step in providing more in the application. So the idea behind the GraphQL stack is it's really just a standard SST app, but the starter for it comes prepackaged with a way to build GraphQL applications, full stack, end to end. So this doesn't really mean we're going and building a bunch of things. We just spent a lot of time trying out some of the really great tools that exist out there in the GraphQL community and picking the best ones and putting them together in a way that makes sense. One of the things we really looked out for is end-to-end type safety. It's one of the best benefits of even using GraphQL in the first place. But not a lot of people really have the time to actually get that all working. So we picked tools that really highlight how great end-to-end type safety can be, and we put those together for a pretty good experience. So in this talk, I'm going to show you a really basic application that I've already built on the GraphQL stack, kind of show you how it works behind the scenes. And then from there, we're going to be building a new feature on top of it. So that will be live coding, and we all know how that goes, but hopefully there will actually be some issues because that'll highlight how TypeScript helps, catch those in development fairly quickly. So yeah, to get started, I have this if you look on the right, I have this very basic application here. It's kind of like Hacker News or Reddit. You can submit links, and then there's a homepage that has a list of all the links, all the links for you. So cool. You can see I just added one there. So this is just a standard SST app. If we look at the stuff on the infrastructure side, I'm using the new functional stack setup as a database stack, which just has an RDS cluster. We're using Cognito, but I'm not really going to be going too much into that in this talk. It has an API, which is a GraphQL API, and it has the front end, which is a Vite static site. Cool. So to start about how this is actually powered, we'll go to the deepest part of the app. So if you look on the left, we have this new core folder. So this folder really just contains all the core business logic. It doesn't really have too much to do with GraphQL or serverless. It really is just representative of all the business logic that your application contains. So we have this article module, and in this article module, we have two functions, create and list. So create will create a new article, taking a title and a URL. Lists will return all the existing articles. And these functions are implemented by talking to the RDS cluster. We're using a library called Keysley to talk to the RDS cluster. If you're familiar with Prisma, it's kind of the same. It's a type-safe way of querying your database, but it's purely built with TypeScript. It doesn't require any code generation. It's all done through inference. So this is the core. It really just exposes these two functions, create and list. As you can see, we have our table definition here for the articles. So then let's look at the GraphQL part of this. So if we go into our GraphQL function, we have this article file. So if you're not familiar with GraphQL, it's pretty simple. It might seem intimidating at first, but it really is simple under the hood. It consists of the concept of commands, and commands can either be queries or mutations. Queries fetch data out, mutations take some kind of write action against the API. So if you look, and the third concept is types. So queries and mutations return types, and you can use types to describe the various entities that exist in your system, their fields, how they're related to each other, and it's a pretty powerful tool to define all of that. So in this example, we have an entity called article type, and all of this is built using a library called Pothos. So Pothos is a way to build GraphQL schemas and GraphQL APIs in the backend just using TypeScript. You're not defining separate GraphQL schema files. You're doing it all through TypeScript. It's built in a TypeScript first way, so it really relies a lot on inference and can do a lot of really cool things, which you'll see in this demo. So we're using that to define this article type. And we're saying this article type is backed by a SQL row. And we have some fields on this article type. We're going to expose the ID, the title, the URL. So this is just shorthand to expose a field from the database row directly into your API. That's what we're doing here because it's simple. Pothos is not coupling your API and database together. You can back any type here with a single database row, multiple database row, some other third-party source. It doesn't matter. You can modify the data before you expose it. So this is not a tool that just exposes your database through GraphQL. You have full control over what your API looks like and how it behaves. And then from there, we have a query. So this is an articles query. It returns a list of article types. And to resolve it, we're just calling that list function that we exposed earlier. Pretty simple. So then we have a mutation field. So this is for creating an article. So this returns a single article. So this will be the article that you created. It takes some arguments, a title and a URL, which are both strings and they're required. And to resolve this, we're just going to pass those arguments into the create function that I showed earlier. So pretty simple. This is all you need for the API for this GraphQL setup that we have here. Now the fun part is a look on the front end. So this gets to show off the end-to-end type safety. So if you look on the front end, so this front end is built with React. Our starter GraphQL stack is not coupled to any front end approach. In this demo, it's going to be React. I personally have been using it to build with Solid.js. It will be compatible with Next, whatever you want on the front end. We're not opinionated there. I think in general, with these stacks that we're going to be putting out, think of them less as full-featured frameworks and more like a bunch of primitives we've assembled together that we find useful. If you disagree with any part of it, you can swap it out for whatever you want. So on the front end, we have this new use type query hook. And again, this is very React specific. So this is completely type safe. So you can explore your whole API right here. So you see we have this articles query that I showed you earlier. You can specify that, okay, I want to fetch the ID, I want to fetch the title. I want to fetch the URL, right? And the response type here is also typed. So in the UI, we're mapping over this articles type, and we're showing the article title, the URL, and we're not really using the ID, so we don't actually have to fetch that. If you delete some of these fields from the query, you'll get type errors down here because you're not actually fetching it. It'll be null, and if you look on the right, it blanked out. So you'll get type errors right there if you accidentally do something that your API doesn't support. So this kind of demonstrates what's great about using GraphQL. Because you have a strongly typed schema on the back end, your front end will always be in sync with your back end. You're not manually defining anything on the front end to fetch from certain endpoints. All of this is automatically generated and inferred. You're never going to run into a situation where something has changed on the back end and your front end breaks without you being aware of it. The type checking will catch those errors. It's also helpful in building backwards compatible APIs, because in the back end, if you remove a field and you run your type checking on your code base, you're going to get errors saying, hey, you actually broke the front end from doing that. So that's why end-to-end type safety is important. It really pushes the idea of single source of truth. And that's where you go and modify things, and everything downstream should infer from that. So that's the basics of how this existing application works. So now's the live coding part. We're going to add a new feature to this application. So we're going to add the concept of comments. And so you're going to be able to look at this article. You're going to be able to send whatever terrible comments you want against it. So we'll start with, again, going back to the core. So the place that's least tied to our API or our article, whatever. So we're going to add 2 new functions here. Let's add a function for comments, and this will just take an article ID and list comments. We'll add another function to add a comment. It'll take an article ID, which is the article you want to add the comment to, and the text of the comment that, the text of the comment that you want to make. Okay, we have an idea what we need to add. Let's figure out how we want this to work in the database. So before we even write a migration or anything, let's just use Keysley to think through what we want here. So let's make a new comments table. Each comment should have an ID. That makes sense. It should have an article ID, because it's going to point to the article that it belongs to. And of course, it's going to have the text that it requires. So to add a comment, we will insert into, and you can see the type safety here. You got the comments table, of what values we're going to insert. We got type safety here. It knows exactly what you need to insert. For the ID, we'll generate a new ULID. For the article ID, we'll just pass through the article ID that we're getting in the arguments. And then for text, again, we'll pass through the text. And then we'll execute that, and then take first. We'll also return all the columns, so we can just return the row that was inserted. Cool, that looks good. And then for listing a bunch of comments, let's use Keysley to, now this time we're going to select from comments. Let's just select all of the columns where so you have the type safety here. You get autocomplete, where article ID equals the pass in article ID, and then we'll execute that. Awesome. So this looks right. This makes sense. I think we should write this table to the database. So because we're using the SST RDS construct, it natively supports migrations. So we can write a migration right here. So we'll start off with this existing one, and we'll call this second. This isn't best practice. You should put the timestamps in there, but it's fine for the demo. And we'll clear out most of this. In the database schema, we're going to create a new table. It's going to be called comments. We're going to add a column called ID. It's going to be text. This column is going to be the primary key. It's all the autocomplete here helping me. I don't really have to know too much about or memorize how to add tables in Postgres. So what else do we have? We had an article ID. It's also going to be text. And then we have a text column that is text. And let's execute that. Make sure we await it. And let's just specify a down migration as well. You probably shouldn't be using this in production, but it'll be helpful in a local development. So to turn off the migration, we're going to drop the table. Let's give me a warning because I forgot to execute it. Cool. So Now, if you hop to the SST console, I actually use it in light mode. I think I'm the only person that ever uses it in light mode. If you go into the RDS area, you can see that this new migration has popped up here. We can apply it. It's been applied. Let's just double check to see if it worked. Nice. We have this new table called comments. Okay. Now we're good to go on the back end. Now let's work on the API. So for the API, we're going to first start with a new type. So we're going to have this new comment type to represent a comment. And we'll use Pathos to define it. Pathos is great documentation, so you can refer to them to figure out how to do this. It's going to be backed by a row from the comments table. And the GraphQL type is going to be called comment. And let's implement it. So we'll have some fields to expose here. So we'll expose the ID of the row. And you can see there it auto completed that for me. We'll expose a text. And we can expose that right there. And you don't really need to expose article ID. So this is an example of your database row doesn't have to really map one-to-one with your API, and they should be different in most cases. And then we're going to go to the article type and say there's a new field on each article called comments, and it is a field. The type is a list of the comment type that we just defined. And to resolve it, first argument to all the resolve functions is the parent. We're going to call that function we just made. Article comments, we're going to pass in the article ID. And if we messed anything up here, you actually get a type error here, like if you forgot a column to return. But we didn't, so that's good. And then we're going to add a new mutation called add comment. And this is going to be a field. The type is going to be a comment type. It's going to return the comment that just was created. We're going to take some arguments, right? So we'll take the article ID, which is going to be a string. And we'll take the text, which is also going to be a string. And to resolve this mutation, we are going to pass those arguments to article.add comment. And we'll pass in the arguments of the second. And so we see we get autocomplete here on the ones we just defined. So we'll pass in the article ID and the text. And it looks like we're getting an error here. And it's because, let's see, it's because void not assignable to selectable. Because we forgot to return this. Okay, cool. See, TypeScript caught an error right there. Great. So it looks like our API is done, but to test it out, let's go into the GraphQL Explorer, which we have built in. So you see, you can use this to play with it. And this is what we had before, just ID, title, etc. Again, we have autocomplete here. We have this new comments field. And we'll take the, we haven't made any comments yet, so this is going to be empty. So we get an empty array. But it looks like the API is working. So let's jump to the front end and actually implement all of this. Go back to the articles file we had before. So I cheated a little bit. I have some pre-built UI here. Just going to uncomment it. Let's start with fetching. So if you look here, we now have this new comments field that's showing up here because we added it into the back end. We just really care about the text. We don't care about the ID. So this query is now going to also fetch the comments. And if you look down here in the UI, let's flip back to this. We're iterating over article comments. You can see all this is type safe over each comment, and we're going to put the text in a bullet point there. And let's implement a mutation to actually create the comment. So I actually have this commented here as well, and I'll just go over it. Have this comment form which already existed. I'm creating a new mutation. Just like the queries, this is all type safe as well. You're going to get the add comment thing that shows up there. For all the arguments, it's going to show up here. It's going to tell you what's required. It's not going to let you trigger that mutation without passing in things correctly. But we have that there, and we have this wired up to the form. So if we now go and add a comment, you can see it all works. And yeah, so that's the feature. We built that here in probably like 10 minutes or so. One thing I do want to highlight is there are a few layers here. Like I showed you, there's the core layer, there's the API layer, there's a front end. This might feel like a lot for a simple app like this, but one of the things we're really focused on, as Frank mentioned, we want to make it so things are easy on day one, but as your app gets more complex on day 100, day 1000, you should still be using the same pattern. So this might seem a little more complicated than you're used to, but it's something you'll really appreciate as your application grows in complexity. And it's one of the areas that we're focusing on that we feel like is a little differentiated. So yeah, that's everything. I'll be open sourcing this example repo, so you can check it out after the talk. The GraphQL stack is not done yet. We're planning on doing a full release week for it in a month or so. But yeah, that's all from me.
All right, thanks, Dax. That's a great demo. I learned something new about SST today. All right, for next, let's welcome Adam. Adam is a principal application architect and AWS solution architect at Onica, specializing in AWS serverless application development and IoT. And Onica, for those of you who don't know, is a premier AWS consulting partner. Let's welcome Adam to the stage.
Thank you, Frank. So my presentations might sound a little bit like Zach before me, and basically we're taking came from an existing platform and has some pain points and see the wonders of serverless stack. So we're going to use that to simplify things. So thanks for the introduction. Yep, I'm manager of cloud native development at Onica. This is paradoxically a picture of me when I was both younger yet looked older. You can find me on LinkedIn and Hashnode, and obviously on the serverless stack Slack. You gotta be careful saying that. Stack Slack. Okay. So at Onica, we have this reference application to use as a starting point for some of our cloud native serverless projects. And there are many of these around. You find them on publicly available. Because starting up a new Node.js based project requires a lot of configuring this whole big ecosystem of tools. So ours is private. So sorry, I can't share more than this diagram, but you can see that it includes all sorts of AWS goodness around API gateway and Lambda and IoT ingestion, DynamoDB, Cognito. Pretty typical AWS serverless stuff. Don't panic. Next slide is blank. So this was all good, but deployment for all this was quite complex, both in development and in CI/CD. The core infrastructure was handwritten in CloudFormation templates. There were actually 8 of these. I'm just showing you a few. These were organized with a configuration file listing each with their parameters. And the Lambdas, on the other hand, were in serverless stack. But there were 6 stacks of code. So we have the common stuff here in the base serverless YAML, and it imports the content of each stack. As you see here, custom stack, pulling in from the stacks folder, and then down here, functions and resources. I don't know if you can see, it's hidden a little bit by my picture. But we're also pulling in the stack, the resources from there. And also, because this is YAML, we got funky stuff like empty object and empty array, just so we can do kind of hack around the lack of logic capabilities. So, well, of course, now that we have these 6 stacks and growing as the real application is made from this baseline, we need a way of managing all that. So now we have a custom script to manage all of that. And there's a demo app, and of course the real downstream project will have one as well, and it needs to be deployed. So we have our own homegrown open source utility called Runway, and that, of course, is just another YAML file that has to be configured, listing out everything you want the CI/CD pipeline to deploy. So now, with all of that, our developers and our CI/CD pipeline can run a command, deploy each CloudFormation template, each serverless framework stack, and the web app one at a time to completion in sequence. And this is what we had to do for just a modest-sized serverless application. And then serverless stack popped into existence, and we migrated over. Now all our infrastructure is one place under the stacks directory. You can see we have our, this is the account API I have open over here. We have the API stack, and we have the Lambda handlers for that stack right next to each other. It's all in one language. There's a TypeScript. This is from the index.ts file. And it's the same language as the implementation of the application. So now, no more YAML, no non-node tooling, just npm install and run. The stacks deploy in parallel when the dependencies allow it, not purely sequential. So this is my simple summary here. You start off writing an app in TypeScript. It's all good. And then you try to deploy it. Now I got to deal with serverless framework and CloudFormation and YAML. Oh, we got to Webpack all that together. It's getting complicated. Better throw in some shell scripts and runway. And it's just this horror show. And then we migrate to serverless stack. And all we have is TypeScript and serverless stack. That's the journey we took. I know that this is a very brief run through. Other people went further in, but I sort of like to hit the punch here of serverless stack takes the mess and makes it clean and simple. And that's what I got.
All right, thanks, Adam. Man, really appreciate sharing that architecture. I mean, you know, looking at some of the folks like Adam, what you guys have built in the community, it really it's at a scale that I could only imagine before, and sometimes even like question like when I talk to Dax and Jay, and be like, like these people they're building more really advanced applications, right? How can we keep ST up to speed to make sure they don't outgrow SST? And so one of the solution we came up with is we need to pay more attention, and then keep learning from what these guys are doing, and then take the feedback and build that back into SST. So thanks again, Adam. Next up, we have Robert. Robert is the CTO and co-founder of HeyDaily. That's a platform that allows creators to monetize their audience through white-labeled subscriptions. All right, the stage is yours, Robert.
Thank you so much, Frank. Hopefully if I click this, it will bring up the slides. Or someone else clicked it and it worked. But yeah, thank you so much. Great to be here. My talk is a little tale of our transition from what was a Java Spring application, our MVP tech stack, over to SST. And we did it this spring, so I called it Springtime for SST. So a little bit of context to start with. At HeyDaily, we're building like a way for creators to deliver exclusive content in the easiest possible way. And the way we do this is we deliver SMS messages to their subscribers that has a link to content that has images, videos, and voice notes. And it can also have a bunch of text. But the important thing is, that we're kind of have a bunch of, this will come in later. So a little bit of context. So what we were working on before was a Java Spring application, and it was kind of a microservice-based thing. And for those that don't know, Java Spring is much like a tools included framework, batteries included framework. So it has things to like interface with databases and kind of do service discovery, but it makes deploying on the cloud really very hard work. And to get something working, we deployed on ECS. We used Fargate in the end, just to be super simple and not have to manage kind of resources. and we used the CDK as well because that was a lot easier to use than Terraform or CloudFormation. No one likes writing YAML, as we've heard multiple times today. And then our application has to interface with a bunch of other external services. We use Mux for video, Twilio for SMS, and Stripe for payments. But there are a bunch of issues, and some of these issues just could be resolved with more time and more investment in the developer experience. But some of them couldn't. And so one of the big ones was, hey, it worked on my machine, but then when we deployed to our staging environment, because of the differences between kind of the local development environment and the sort of staging environment that's all in the cloud, different kind of database versions between RDS and kind of the local in-memory database, different service discovery, different permissions, you suddenly discover that what you thought worked doesn't work. And the iteration cycle to get your next deployment up onto the cloud and to see if you've managed to fix the issue is very long. The other issues, kind of to run these microservices locally, you have to kind of orchestrate some quite complicated Docker Compose magic. And then once you've got Docker running and you've got databases running and you've got Redis running and you've got a bunch of microservices, and then you're trying to compile your Java code, you're then in need of trying to download more RAM, which, as we all know, doesn't work. And lastly, I know someone earlier today was mentioning sort of a 3 to 5 second developer loop. Well, coming from my personal background, kind of JavaScript and Python, having to compile Java code, which takes maybe sort of 30 seconds, and then build your Docker images, and then spin up Docker Compose to then actually get your end-to-end tests to run. Yeah, there's an actual footage of me waiting those 2 or 3 minutes that it took. And then in February, we made a great discovery. I came across this article by the guys at Plane that described what seemed to be a beautiful developer experience for serverless using serverless stack. And we did some investigation, and that kicked off our conversion into SST, full stack TypeScript. So why SST for us? And I'll start by saying sort of why serverless, and a bit like this little furry friend over here, our loads are quite spiky. So we send out messages to our subscribers, or our influencers send out messages to their subscribers, and then all the subscribers tend to open those at pretty much the same time, which means that our loads are very, very spiky. And the kind of beauty of serverless is you only pay for what you use, and you don't have to kind of provision servers in advance for kind of either your provision to the max kind of expected spikes, or kind of have some dynamic scaling that sort of takes a long time to configure. So serverless is an amazing thing for that. Unfortunately, it's often there's not the greatest developer experience with serverless, and often you're had kind of come across serverless back in the day and having to kind of manually package your Node modules or your Python modules into some like the right format to upload to AWS Lambda was difficult. And I know that like over the years it got a lot more easy with kind of serverless framework. But even so, the development cycle wasn't fantastic, and the difference between dev and prod, especially if you were or sort of local development and deployment, was still problematic. But then serverless stack came along and kind of changed the game a lot. So the full stack TypeScript nature is awesome because it means that the same developers can work all the way from infrastructure all the way up to the front end. And when the company priorities change, we can kind of change we can make use of everyone in the area that's most important. The fallback, well, so firstly, the abstraction of CDK to an even higher level abstractions is amazing. It means that there's a lower kind of cognitive effort required to understand, okay, I need to create an API gateway, then I need to create some certificates, and I need to do a Route 53 like DNS record, and I need to, so that's all hidden behind some very nice abstractions. And like hooking that up to Cognito is super easy. But not only have they got these good abstractions, the kind of escape hatch, as people have described it, mean that we're not going to be limited by SST not having a particular functionality. And that's like a really, really big important thing for anyone sort of choosing a tech stack. Am I going to be stuck from doing what it is that I want to do? Also, another couple of things to seed So a lot of the problems we mentioned earlier about the kind of Java Spring ecosystem, a lot of those could be solved by heavy investment in developer experience. Not completely, we still wouldn't have been able to kind of put together really fast builds for Java necessarily and really like quick deployments, but we would have been able to have, for example, PR branches done by kind of segmenting our RDS instance and having some kind of keys on the S3 bucket and things that mean that you can still deploy every single separate user rather than just having a staged approach. You can still have MR branches, but it would have been a lot of effort. And then seed is awesome because within like a tiny amount of time, maybe about an hour spent configuring, because we've little nuances with GitLab. You have every PR has its own branch. That's all deployed. The integration tests run. That's awesome. And we're sort of one thing we haven't yet used, but we will want to be doing is kind of server-side rendering. And it looks like, and it had support today, there'll be even more support for kind of things like Next.js and server-side rendering from SST. So I don't have a huge amount of time in this overall talk, but I want to give you kind of one example of something that was especially awesome. So in our old stack, we have a bunch of things where there's webhooks, and specifically like the Stripe webhook is very important because every time there's a new customer, we need to kind of do some actions based on that new customer existing, or if a customer unsubscribes, do some actions. And in the past, you would have to sort of spin up ngrok to expose your local ports out to the internet, and then go manually into kind of Stripe and update the webhooks in Stripe to then kind of do any tests, which would be manual tests. That if you had automated tests, they'd always fail until you've done this manual step. So what it basically meant is most of the webhooks didn't really get tested, and they didn't really get tested manually, and they only discovered problems when they were breaking. But with SST, one thing that we've done, which I think is awesome and kind of really shows the power, is we have a script, an SST script that on the before deployment script, it calls to the Stripe API and hooks up the webhook between the Stripe API and the URL of the deployment for our webhook. So whether you're running it on your kind of SST start or you're doing it from a PR branch, all those Stripe will always be hooked up to any deployed instance or any SST instance. And then we have an on-destroy script that cleans that all up. So what that means is we can have end-to-end tests checking like if a new Stripe customer gets created, do we do the right actions based on that? So that's kind of a really awesome thing, and it's kind of removed that kind of developer overhead, the time it takes, and or just even in reality when you're a startup, you choose to let's not bother with trying to implement those integration tests because it's going to take too much effort. So it's giving us kind of better code, better more reliable code, and more confidence that things work. The other things that are awesome, so the serverless stack Slack channel, that really is a tongue twister, is great. Both the serverless stack team and the community there, if you've got any issues, people are kind of jumping in, kind of, I've seen this before, it's this, or discussing what's the right framework to use, or the right patterns for tackling some problems. So can't shout out more love to that. And the full stack TypeScript nature is also great because I've thoroughly enjoyed importing the interfaces that we defined in our backend into our front end for things like the request body and the request response. So there's none of the disconnect between front end and back end where you've kind of redeclared your interfaces in TypeScript that are declared previously in your Java classes, and then actually they fall out of sync, and then you get bugs that appear. TypeScript hold your hand for you, and it's amazing. A few things we're still figuring out. So DynamoDB, there's things like how we're going to do migrations. Probably going to use an SST script, but we'd love to hear any discussion in the Slack channel about the best way to do that. What ORM we should use, what's the best kind of single table design patterns, and then other things, kind of CloudFormation, because we have a lot of interstack dependencies. We get occasional times, especially in this early development stage, where we've renamed something and it goes, you can't like this. It tries to deploy the new thing alongside the old thing, and the old thing has the same name or the same. So that's somewhat problematic and it's a bit of a pain, but we're getting more used to dealing with it, and hopefully people hopefully it'll sort of calm down as our stack gets more and more stable, and we're only introducing kind of new features rather than kind of working things out as we go. Yeah, so in summary, our DevOps overhead has reduced. I wrote 10x. It's probably bigger than that. It's like a huge order of magnitude decrease in effort for DevOps. And not only that, but we've also got this superb developer experience. It's super fast. It's type checked. The abstractions are clear on the infrastructure. And there's no more kind of it worked on my machine issues. It's like we're already testing it in the cloud against the genuine cloud resources with these kind of deeper end-to-end tests. So yeah. Last thing to say, yeah, we're hiring at HeyDaily. We're looking for some great full stack engineers, great front end engineers. So if you're looking or you know anyone that's looking, reach out to me, Robert at heydaily.co or on the Serverless Stack channel. Thank you so much, and over to the next person.
All right, thanks, Robert. You know, every time I talk to Robert, I can't cease to amaze me that someone so young and good looking as Robert is a Java developer. So welcome to TypeScript. All right. So but honestly, I think the talk builds a lot of confidence for other teams that are looking to move over to serverless and AWS. All right, we've got Albert next. Albert is a software engineer at Shell Recharge Solutions, and interestingly, he studied pure mathematics and was part of the International Math Olympiad in the past. All right, Albert. The stage is yours.
Good morning, everyone. My name is Albert Hoxha. I am a software engineer for Shell Recharge Solutions, and I'm going to talk about our experience with Serverless Stack in our team. I'm a software developer for the business API team. I work only on backend services, and as it is with almost every other company, we are also transitioning every new service that's getting built to a serverless architecture using AWS as a cloud provider. And we are doing that by using the serverless stack as a library for enabling us to build the CloudFormation files and deploy our infrastructure in AWS. This is basically an introduction in the beginning about what I do. We are building a lot of services. We mostly serve as a gateway between internal systems communicating with each other, or gateway between external systems and internal systems communicating with each other. So we will have to deploy a lot of services, and we decided to use the serverless stack. I have organized my little speech in some questions and answers. So the main focus of what I will talk about is why SST. And the answer for why SST is because SST, so there's multiple reasons, but the main one that I wanted to focus on is how the serverless stack framework has enabled us to test our services. What do I mean by that? Previously, we were using the serverless framework, and whenever you wanted to test something which is basically hosted in AWS and everything is on the other side of your machine, it's really hard to mock, and it's really hard to create a real-time environment in your machine of what's going on with your application. So it's not that we are now in the traditional way of building web services, where you would have everything running in a server and you could just run the application on your machine and you could test things in real time. And now the things are scattered. You need to know what data invokes. Let's say you have Lambda functions, and you want to know what does the data that invokes my Lambda functions look like, depending on the resources. And in order to do that, there's ways to do that in serverless, also in other frameworks. But I saw that it takes a lot of time for the engineers, and sometimes it's really hard to mock things. Let's say you mock or you use a plugin for mocking a certain resource like DynamoDB or whatever. The next day, AWS might change how that resource works. So it might change the data that gets sent by the events and all that. Who knows? And the plugin will not be up to date. Your tests will pass. Everything will work. The real thing is not as we want it to be. Now, where is the power of serverless stack in this regard is at the debug stack. when you have Lambda functions, you can, as you know, test them in real time, in the sense that the code that runs within the Lambda function will be running from your machine, and everything else is the real deal. This makes it extremely powerful because that's basically what you would want. It's like the answer to the question, how would I want to be able to test services that are hosted, that are built using the serverless architecture? And that's basically how you would want to test them. You would want the business logic, which is usually written in your Lambda functions, to be able to run in your machine, while the data coming to that piece of code is the real deal. And that's what Serverless Stack offers us. So in a way, we are always ready to test everything. I can give an example of like a small problem that we had in the past that was solved immediately when we switched to Serverless Stack. We had this Lambda function that was getting invoked by an S3 event that was fired through a certain action you would do on an S3 bucket. And the file names are encoded in the event. But when we were doing the mocks previously without using SST, people were building the code in the handler and also the tests in a way that the file name would be mapped one-to-one, exactly the same. Turns out that's not the truth. Turns out that the AWS encodes the file names when it fires events to invoke Lambda functions through S3. And if you would just test it like that, it will seem like everything is fine. When you would deploy, the code and the Lambda would just it wouldn't work. And when you use SST, you test things in real time. You see, okay, is my Lambda doing what it's supposed to do? You know that the event data is the real deal, and that gives you a great deal of comfort while building your services, apart from doing unit tests and all that. But it's also important to be able to test it real time. What is the other aspect that makes SST the choice for us? I put down the fact that it has a great, helpful community. Frank and all the other people, the founders, are always willing to interact with us as developers. I found it extremely comfortable, and I found it extremely easy to reach out to people and to ask them questions. And I found their replies extremely fast, which is also really nice. So the community also is really nice. It's helpful. It's there to help you. It's there to guide you. And this takes me to the last aspect of why we think SST is quite good to use. It's compatible. Basically, it's built on top of the CDK, but its compatibility with the AWS CDK, together with a helpful community, makes it virtually for you possible to build anything you would do manually in your AWS through code. And it's literally infrastructure as code, because you're writing your stacks through code, and that makes it much more flexible, much more easier to write logic, because when you're writing like YAML files, it's also possible. But I see, if you're a developer, it's much easier to be flexible. And let's say you want to deploy your Lambdas in a VPC when you are in a certain stage in accept or production, but you don't care about that on your test environment. So writing these kind of logic for your CloudFormation files is much easier in code. And that's basically it. I hope I covered some of the key points of why SST is really nice for us and why we use it. I really wish to see this community growing a lot, and I see a great future ahead. I think SST is going to probably be the leading framework for building stuff when you're doing a serverless architecture through AWS. I truly believe that, and it's not because I use it, it's because we tested a lot of stuff and we ended up with choosing SST. Thanks to Frank for giving me this great opportunity to be able to talk to you, and I hope it was nice.
All right, thanks, Albert. Yeah, we hope so too. We also generally hope SST become the dominant way to build serverless applications. All right, and finally we have Luke. Luke leads the engineering team at the Lego Group. And they're building the serverless payment platform that powers Lego.com. And he's an AWS community builder and loves to talk about all things serverless. Let's welcome Luke.
Hello, everyone. I am Luke from the Lego Group. It's great to be here at the SST V1 Conf. Huge congratulations to the awesome team over at SST for this incredible release. So many cool new features. If you haven't had the chance to check it out, definitely go and do that. I'm delighted to get the opportunity to speak to you all today about continuous serverless delivery. So let's get started. Now, let's be honest. Serverless engineering gets a bit of a bad reputation. Some of the things we perhaps took for granted in a more traditional setup, say working on a server full or front-end app, are tricky when it comes to serverless. Opinion is still fragmented when it comes to local development. Do we emulate the crowd and have all the overhead that comes with that? Or do we push to the cloud and endure a slow feedback loop and longer iteration times? Strategies for testing serverless applications are also still poorly defined. Serverless apps are highly asynchronous, event-driven, and cloud-native, and this makes them difficult to test with traditional approaches. And finding problems in production and debugging those problems is often extremely difficult for the same reasons. But there is a better way. We can help serverless engineers to feel productive again by baking delivery to the cloud into every step, from keyboard to production. No more waiting for infrastructure and logic to deploy. We can have fast feedback loops again. No more disjointed DX by putting everything back into the IDE. No more complex local environments for engineers to set up. We can be productive in minutes, not days. By applying techniques and using some of the amazing tools out there like SST, we can spark some creativity back into everyday engineering by making it super easy to contribute code, while also improving stability by reducing moving parts. We can make software delivery a habit. Now, to illustrate some of the tools and techniques available to you for practicing continuous serverless delivery, let's take a look at a simple example. We have a webhook ingestion service here with an external webhook request producer. The webhook producer sends HTTP post requests to our API gateway endpoint. Behind this endpoint, we have a single Lambda function that is responsible for parsing the request, forwarding it onto an event bridge event bus. You can then imagine we would have multiple downstream subscribers listening to these events, but for now we'll just focus on the core of the application here. So, we are an engineer. We've just seen this bug ticket come in. Webhook messages are not being put on the event bus. So, it's time to dive in, debug the issue, figure out how to fix it. So let's jump on over to our workspace. Now, what we have here is a cloud-based remote development environment. This is not running on my local machine. This is using a service called Gitpod, but there are many other ones out there. So have a look and choose which one best suits your workflow. It runs in VS Code, works exactly the same as the setup that your engineers will be used to. But the difference is there's nothing to set up on a local machine, no dependencies to install like the AWS CLI, no other packages to set up. Everything is automatically provisionable and shareable across the engineering team. Now we have a few things running here that are going to help us. We have our live Lambda dev environment courtesy of SST Start. We also have a AWS CLI logs command running to tail event bridge logs. And we do that via our SST stack. There's a log group provisioned here, and then a simple rule that just forwards events onto that log group. We also have our API defined in here. We have our ingest webhook function as well. It's all looking okay in terms of the stack. Let's jump on over to our function code and try and debug this to see why our events are not being put onto our bus from this function. So we have our handler here, and we have a few error cases that we can look at. Now, if the event body is not defined, we're going to return a 400 bad request. But we know that, so we can see if that's the case. Let's send a message to send a request to our webhook ingestion service. We have a little script to do that. Send message, and we give it a little message to send along with it. So let's hit our endpoint. We've got a little breakpoint. We'll just skip over for now. So we see that we're getting a 500 code back. We see our logs in our SST environment. The function was invoked by API post request, and the status code returned was indeed 500. So we can be fairly certain that we're not hitting this error condition. So the next one is we try to parse the event body string into a JSON object, and if we can't do that, we're returning a 500 code. So maybe the error is somewhere around here. Now we can put in a breakpoint and inspect that via the VS Code debugging feature. We have our SST config all set up there and running. So if we hit that endpoint again, we hit our debugger, invocation is paused, and then we can go ahead and inspect what's actually happening inside our function. So we can see here the full event that we get from API gateway into our Lambda function. We can see that the body looks okay there. Message hello, that's what we sent. We could inspect some headers. Perhaps you'd have authorization applied to this endpoint, but we don't have anything like that implemented here. So that all looks okay. And then we also have our event body variable. Again, that all looks fine. It does look like the JSON parse was successful. We were able to get the JSON object from that event body string. So again, we can be fairly certain that the error is not coming from here. Indeed, we got to the breakpoint and we can see that everything looks okay. So we just hit continue on that, and the function finishes execution. So now we get to this try catch, and this is where we try to put the event onto EventBridge. And we have our catch statement here. So we could go ahead and log out this error and see if this is indeed where our application is failing. I hit save on that. SST will build that function, of course, and that log's gonna be ready for me the next time I hit my endpoint. So we go ahead and do that. Oh, forgot to remove the breakpoint. Let's hit continue. And we get an error. So we can see here it's an access denied exception, and it's looking suspiciously like an IAM permissions error. So we can see the execution role attached to our Lambda function is not authorized to perform put events on our webhook bus. So we can remove these debugging helpers, as we know now that the error is not actually in our function. It's going to be over in our stack. So we jump back over to our SST stack, and indeed, when we inspect our function a little closer, we can see that it hasn't got any custom IAM permissions applied to it. So we go ahead and use the handy SST API for applying permissions, and we're just going to give that function permissions to put events onto our webhook bus. Now SST is going to pick up that there were changes to our infrastructure, and we're going to hit enter to redeploy those. That's going to get pushed up to AWS now. We removed all of our logs and breakpoints. So next time we hit our endpoint, we're hoping to see a nice 200 status code. And don't forget our event logs tail here. What we expect to see here is a CloudWatch log to say that the event was received on the event bus. And we all know that everything is working as expected, but let's wait for that to deploy, and then we'll send the request. Okay, that's all done. So I hit the endpoint again. We do get a nice 200 status code. We can see that in the SST logs as well. And there we go. We finally get our event log through as well to show that an event was indeed put onto our event bus. We can see the source of that was our ingest webhook function, and we can see our hello message there as well, and a recent timestamp. So there we go. That is a nice demo of how we can use tools like Gitpod and SST to debug issues in production, speed up our local development, and help with other things like testing locally. So there we go. Thanks so much for coming along to the talk. I hope you enjoyed it and hope you enjoyed the rest of the conference. Thank you.
All right, thanks, Luke. All right, everyone, to wrap things up, we now have Jay, our co-founder and CEO, to give us the only non-technical talk of the day. All right, let's welcome Jay.
Thanks, Frank. Yeah, let's put the slides up there. Yeah, it is a non-technical talk. There isn't a whole lot to go over. I'm hoping to maybe pull a couple of the things together that were talked about today, and give you maybe a behind-the-scenes look at us. So sort of my closing remarks here are titled about SST, but really it's about the team in some ways. And we had a question in the Q&A that was sort of touching upon this, and maybe this will hopefully be a little bit more timely. Again, I'm Jay. I'm the founder and CEO of SST. Before we wrap things up, I want to take a step back and maybe pull the curtains back a little bit about how we work. You've met a couple of us from the team already. You've probably interacted with us, in Slack in some way, shape, or form. But I think the conference gives us a chance to give more of a personal look at us in some ways. The talk will be short. There isn't a whole lot that I have to sort of cover here. And in some ways, I think Frank sort of did a little bit of that for me already. So we wanted to give you a sense of how we all sort of started. And I think Frank's covered that in the keynote. But the areas that I'm going to kind of look at are, what are we building? What are we trying to do with SST? What is sort of our goal here? And how are we going about sort of building it? And I think that might give you a sense of why do we do the things that we do, both in Slack and just in general with some of the design patterns that we sort of follow. This is the sort of tagline, and I think you've probably seen this in some way, shape, or form on our site. With SST, we're trying to build a full stack open source application platform that deploys to your infrastructure and helps you go from idea to IPO, or in this case, it works from idea to IPO. If I take a step back a little bit, we've heard from a bunch of speakers about why they sort of pick serverless. But again, if you go back to sort of the original premise of serverless, in some cases, it was the idea that you would just have to write the code and everything else would sort of be taken care of. And that's kind of the holy grail of the whole space in many ways. And that's is sort of what we're chasing with this. And when we're trying to build out an application platform with SST, that's sort of what we're trying to do. We're trying to get it to a point where, as developers, all we have to do is just write the code. And everything else, in this case, let's think about, defining your infrastructure, the local development environment, the libraries that you use for your application code, the libraries that you use for your front-end code, how you handle deployments, how you handle your database migrations, how do you run tests, unit tests, integration tests, observability, analytics, data warehouses, so on and so forth. There's a whole slew of things that you have to kind of work your way through as your application gets more complicated, as your product becomes more more comprehensive, I guess, and as your team begins to grow from maybe a couple of people to a couple of separate teams for separate functions or features that your product tends to have. And so the guiding principle for us in some ways is this idea, and this is something that Dax sort of touched on early on, Frank mentioned this as well, is that you should be able to start with a stack or a set of tools, the best set of tools that is, and grow with that as in this case, your company goes from idea to IPO. Now, this is not strictly for startups specifically, but that's at least the way we sort of think about this, is that you should be able to start with something day one and work with it in day 1000. And if I just sort of double click into this idea of the sort of idea to IPO thing a little bit, again, it is a bit buzzwordy here, but the key premise here is it should be both easy to get started and completely customizable. I think typically as an industry, especially developers or developer tools, I have at least personally felt that we've always had to make this choice. You either go out and pick a tool that is really, really easy to get started, and you like crank out your project over a weekend. But if you had to pick something that you wanted that would potentially scale, you had to pick something very, very confusing or very, very complicated. And it shouldn't be like that. You shouldn't have to pick between these two things. You should be able to make choices that help you get started quickly, choices that that you don't end up regretting later, choices that you don't have to migrate away from at some point, choices that when your company gets a little bit larger and all these sort of new folks join, they come in and they go, hey, wait a minute, why are we using this again? Why don't we use something else? Like, this is sort of stopping us from doing what we really want to do as a company. And so we want to go out and build that. And I think on some level that hasn't existed. And that is, again, sort of the quote unquote holy grail that we're sort of chasing here. The concept that SST works for both a solo developer and works for a team that eventually grows and potentially goes sort of public is what we want SST to be. And I think we all recognize, and in me just sort of even saying it, you probably sort of recognize that this is a tall task. And so we've put a little bit of time into thinking about how we would go about sort of solving this problem. How do we go about sort of building this? And this was, I think, the question that Omi had during the Q&A, was that how do we sort of balance answering questions in Slack, working on medium-term things, working on long-term features. And the way we sort of go about it is I think unique in some ways. So the first thing that we do is, we sort of take a step back and we look at, we want to solve the problems in the order that you would face with a life cycle of an application, right? So day one, you're thinking about local development, right? And so it makes sense that we go out and sort of solve that. You're also thinking about standing up just sort of basic pieces of infrastructure, so it makes sense that we go out and do sort of the constructs bit, and so on and so forth. Now, there's quite a bit down the road, and I'm not going to go into all of that today, but the general flow that we have, and it's not strictly always like that, but the general flow that we have is that we look at what is the life cycle of an application through, sort of start to potentially to finish, I guess, on some level. And then we think about, what are those areas that we can go out and kind of address and make better with SST. And the way we sort of figure that out, or the way we figure out the urgency behind some of what we need to work on is, this whole idea of us being in Slack every single day, working very closely with teams that are in the community. We heard from a bunch of them today, and we're on both sort of proud and really glad that we've had a chance to work with them. But that the feedback that we get from them, and Frank sort of touched upon this as well, the feedback that we get from them gets us to understand, oh, these are the areas that I think we should be focusing on, or this is the order in which we should be working on things. And so again, so a general guiding principle, work through the life cycle of the application, but really work closely with the teams in the community to try and figure out what are the most pressing things we should be working on. And the final one, this isn't quite, in terms of like exactly how we work, but it's one of the guiding principles for us. And I at least personally talk about this quite a bit, is that we want to focus on solving practical problems. We don't necessarily want to be, out there sort of talking about what are the hypothetical issues somebody's going to run into. We want to be talking to somebody that is having a problem potentially, in our Slack, that we're able to either jump on a call with, have a look at their code base on some level, or like have a look at some of the setups or some of the issues that they're sort of facing, and actually fix it out, like not do it in a way that we work on it sort of behind the scenes and then we hope that it solves the problem. We actually want to solve practical problems that that you or your team are facing on a day-to-day basis. That, I think, sort of brings me to maybe one of the other interesting things that if you've worked with us or been with us in Slack that you might have noticed, is that we work a little bit differently. So we go, sort of above and beyond what it would be in a normal, Slack. And I think almost everybody, I felt like in the talks today, mentioned that they had a great experience in the SST Slack or the tongue twister version, the serverless Slack that we have, right? And there's a reason behind why that why we do it sort of differently, and that is one of the things that I kind of wanted to highlight today. So what we try and do first and foremost is we try and answer every single question that we come across in Slack, right? We try and resolve every single issue that people are running up against. And this would be, whether it's sort of Dax, Frank, or me, we try, and I mentioned this, we try and get on Zoom calls with you sometimes to try and understand, hey, I'm not getting the total problem that you're getting, that you're sort of outlining in Slack. Can we jump on a call? Can you share your screen? Can you show me exactly what's going on? And the reason we do this is because the way we work is a little bit unique. So every single person on the team is doing all these three things. This is doing sort of community support, is doing quote unquote developer relations, and doing sort of product development, right? And the reason we do that is because every person in the team should directly or indirectly through the community have felt the pain or the pain points that we want to try and address. So again, sort of go out there, figure out what the issue is, potentially get that sort of replicated on your side, know exactly what the pain point what the other person is sort of facing, or what you're facing in this case, I guess. Go out and kind of fix it, and then go back out into the community and talk about how you solve the problem. I sort of informally call it full stack product development, but the reality of this is we don't want to separate these functions. We want to bring them all together because at the end of the day, we have a unique advantage in that we're building tools and we're solving problems that we as developers face ourselves. We're in a unique position to really understand the problems that we're trying to solve as opposed to solving for somebody else. And that in some ways brings me back to you, the SST community. I wanted to take a second and give a huge shout out to you guys. And this is the part that's going to sound a little bit corny. We couldn't have done any of this without all of you. When we had sort of launched even sort of the earliest versions of SST with the live Lambda development, I don't think we would have had a shot at getting it to where it was today if we hadn't gotten both the sort of delightful feedback or the very precise feedback that we kind of needed to build the product out in many ways. And I'll share sort of a personal bit. This was, I think, it might have been 2 weeks ago where, as a team, we do sort of these weekly calls. And in one of those, Frank kind of mentioned how the time that he set some time aside during the day to kind of go through, or during the week that is, to go through all the questions in Slack. And he mentioned to me sort of offhand that just reading through all of the questions, and in many cases they're issues, right? So they're like bugs that people are running into. And even though he's reading sort of bugs or issues, it would put a smile on his face. And that actually did resonate with me. It is, even for me, sort of, it's the same sort of thing. When I go through some of these questions, when I'm reading your messages, that is what I'm sort of feeling. I'm feeling the sense of like, oh, wow, everybody's sort of, they're actually using this, and this matters so much to them, and we want to try and understand what both the pain points or sort of the delightful experiences that you're kind of having, and then take that back into the product. And so again, a huge thanks to all of you. If I was to maybe think about one of the reasons why we wanted to do SST 1.0 Conf, it was, again, I think, for the community, because it gives us a chance to get in touch with you guys in a way that we haven't been able to so far. So again, a huge thanks to all of you, and I'll pull Frank back in here so we can get things wrapped up.
All right. I think that's everything. Do we want to take any more questions, or?
Yeah, I think we're good. Unless let me take a quick look. I didn't actually have a chance to take a look because I was talking. But,
no, but I think people know where to find us if they have questions.
Yeah. No, I think we're good. Are we good, Dax?
Yeah, I think we're good. I have
All
some
right.
questions in Slack, so I think we're good.
Yeah. All right. Thanks for joining, everyone. Recordings will be up shortly. And if you've got any questions, we are in the Slack channel #help. Just give us a shout. If anything sensitive, just DM us. All right. Until then, we'll see you guys at the next event. And thanks, everyone.
Is that SST 2.0 Conf now?
We should do.
We gotta think of more breaking changes first.
Then we should, we should go launch the GraphQL stack.
Yeah.
We should turn off our mic, should we?
Yep. I'm gonna end the broadcast.